All right, let's talk about measure of dispersion. So first term that I want to focus on is this deviation. So what is deviation? Deviation is how far is your data X from the mean. Okay, so you can calculate it by writing out deviation equals the value X minus the mean. This is the mean. Okay, all right, let's see. So let's say I'm looking for the deviation of test score of 7 students. So you have 7 student score listed here: 3, 4, 6, 2, 8, 8, and 5. So the question says find the deviation of each score. So what do I do? First thing that I will be doing is find the mean. So this is what you do first. Okay, so I'm looking for the mean. I can add all this. So adding all this gives me 36. So 36 divided by 7. So this is about 5, 1/7. Okay, all right, so what do I do next? Then you can be asked to find the deviation. How can I find the deviation? I will make a table here. So I'll put all the values I have here. Okay, all of them I will put in this table. Okay, then what I'm going to do next is I will take this value, subtract it out from each of these values. Okay, so let's see, what do I get? So subtract them out. So if you want a decimal or a fraction, it's up to you. Or if you want a fraction, okay, this I'll just show you here. It's going to be 3 minus 36/7. So if you simplify this, it will give you minus 15/7. So this is the value where you have minus 15/7. Okay, then you can keep on doing the same thing with 4. Okay, so you can go 4 minus 36/7, then it'll be 28 minus 36/7, which if you simplify, you will get negative 8/7 here. Okay, so keep on doing the same thing, subtracting it. Okay, then what you will get is you can also write out the sum here. So I can say this is the sum, okay, of all the x minus x bar. So I'm adding all this, and I could write the sum here. Okay, all right, moving on. Now another term here that is commonly used is variance. So variance measure the total spread of the data. You can highlight that. You can say, okay, so variance means total spread of your data. Okay, this is the meaning of variance. So how can I find variance? I would have to do the sum, okay, of x minus x bar. So this is the sum that I have just written for you here, the sum of x minus x bar. Okay, and then square it. Square each and divide it by n, total number of data. But what happens if we feel that this equation is a little bit too complicated? So what we can do is we can break it down. We can say, okay, this equation can be simplified into this. Okay. All right, before I explain how to use this, let's go back a little bit. So if I want to find variance, what I will do is I will have to make this table here. I will have to say this, the whole thing being squared. Okay, so I have to square this, all the values here, and write them down here. So this is going to be all the positive values, right? So you have to square all this. Now I don't like big numbers because I have to do the summation here. So my trick here is we go with this equation. Okay, so what I'm doing is I will start by first find the sum of x square. Okay, sum of x square, and then this is actually the mean, by the way. Yeah, the mean being squared. So this is like the mean. Okay, and then you square the mean. Okay, all right, let's see how do I do it. So this is all my data sets from the above. I'm putting it down here, square it. So this is 9, 16, 36, 4, 64, 64, and 25. That's all I need for this, okay? This is like the first thing you do if you want to find variance. Then what do I do next is find the sum of this here. This is the second step. You find the sum of all these. Okay, so here you can see I'm doing the sum here. Okay, next you find the sum of all the x square. All this sum. Okay, this is what I'm getting. So I will now be using these two values. First here 36 and the second here 218. Okay, this is what you do first. Then last is we plug into the equation here. See, we got this as 218. See here 218. Right, so write 218 over n, total data. How many data set do I have? 1, 2, 3, 4, 5, 6, 7. So I'm writing 7 here. Minus the mean. See, this is actually the mean, right? X bar. Okay, then simplify this out. You get the value of your variance. This is variance, 4.69. This is very important. You should know how to find variance because we'll be using this throughout the whole year. Okay, so very important how to find the variance. Yeah, okay, then there is another term called SD. It's derived from standard deviation. Okay, standard deviation means this is the measure of dispersion of data set relative to the mean. Okay, so how do I find standard deviation? Just take the square root of the variance. That's all. Okay, so you can see that some textbook called variance as this square, yeah, and SD, standard deviation, is this. Okay, so the relationship is SD itself is equals to the variance being square rooted. Okay, or you can also do this, variance is equals to SD being squared. Okay, so you should know the relationship between variance and SD. Okay, let's see here. Now, can we put the variance and take the square root and write it as an equation? Yes, you can, right? So this is what I'm doing. I'm saying that you just copy the equation of variance. Okay, so the equation of variance is this summation of x squared over n minus summation of x over n, the whole thing being squared. Okay, and then root it. Keep in mind, yeah, that the variance cannot be negative. Okay, cannot be of negative value. Okay, all right, let's see here. So again, your same data sets given to you. The question says find the standard deviation. So what do we do here? You can find the standard deviation by taking the value of the variance and square root it. Okay, so I'm going to square root this value, which is, if you square root 4, it's 2, right? 4.69. If you square root it, you get 2.16. So this is how the data are being spread out. Okay. All right, let's see this question here. So you were asked to find the mean, okay, of route 1 and route 2. Okay, that's easy. The mean, you just add all this. Okay, let me just add it real quick. Let's see what do we get. But first, let's make another table here. Route 1, I will call this R1. Okay, so that is 15, 15, 11, 17, 14, 12. Okay, instead of R1, let's call it X, because we will be asked to find the variance and the standard deviation. Okay, and then this I will call it X square. All right, so let's calculate all this out. All right, so let's see this. So I'm going to find this mean first, X bar. So adding all this, okay, I'm getting 84 divided by total data, which is 6. So I'm getting the mean of 14. All right, now let's do 15 square, which is 225. This is again 225. 11 square, 121. Then go with 17 square, which is 289. Then you go with 14 square, which is 196 and 144. Okay, now let's do this. So as we all know, the sum here, this is sum of x. I just did it there, 84. And this here is the sum of x square. Okay, let's see how much is that. So I'm going to do 225 plus 225 plus 121 plus 289 plus 196 plus 144. So I'm getting 1,200. Okay, now I'm going to start with the variance. So the formula for variance is sum of x square over n minus the mean, right, being squared. This is the variance. All right, let's see, what do we get? Sum of x square is this. Yeah, so it will be 1,200 over n. N is 6 minus the mean square. The mean is that, right? 14 being squared. Let's see, what do we get? So 1,200 divided by 6 is 200 minus 14 square is 196. If you do that, you get 4. This is the variance. Okay, the next part of the question is find the standard deviation, SD. That's easy. SD is variance square rooted 4. If you root that, you get 2. Okay, so you do the same thing for the route 2. So you make a table and follow the step that I just did. Okay,